Greetings, this is Unit 6, Module 4, Session 2. The name of this home connection is Unit 6 Review. It's a two-pager. Please put your name and number at the top. Let's begin. If the area of a rectangle is 306 square centimeters, I'm going to stop right there. Why? Well, because if it says rectangle, oh my goodness, we might as well draw one, don't you think? So let's see what I have here. I can draw one of these. Doesn't have to be perfect, and I don't exactly know what size it should be. So I just draw a rectangle, and then I continue. The area is 306 square meters. So I know that the inside of this rectangle is 306 square centimeters. Okay? Area is the space inside, the number of squares that would fit inside if they were 1 centimeter by 1 centimeter. Let's continue. One dimension is 6 centimeters. Well, I always kind of like to make it just the left side, and then I always think that's the missing one. But you can do it whatever works for you. Your teacher might have a different style, and that is completely fine. At this point in time, what are we going to do? Well, it says, what is the measurement of the other dimension? And you can do this however you would like. I'm going to show you a way that I enjoy that I think is predictable and effective. And the ratio table is nice. One thing that I try to do when I set up this ratio table is try to figure out logically what could I count by that gets me there faster. Because if you had all day, you could say, well, 1 times 6 is 6, 2 times 6 is 12, 3 times 6 is 18, and you could do that until you get to 306. I don't want to do that. That's going to take too much time. So I'm going to see if I can get rid of these, and maybe instead of counting by ones, like 1 6 at a time, what if we count by 10 6s at a time? Okay, so, and remember, all of these are 6 times whatever is in this side here. So 6 times 10 is 60. Okay, what if I add 10 more? Now I have 20. 6 times 20 is 120. What about 6 times 30? Well, that's 180. What about 40? Well, 6 times 40 is 240. What about 6 times 50? Well, that's 300. Hopefully your mind noticed. We're trying to get to, that's not what I wanted. Let me fix that real quick. We're trying to get to 306. 6 times 50 is 300. We are so close. So what if I just add one more 6? Oh, I did it again. Let me get rid of that. I'm supposed to be over here. What if I add one more 6, and now I have 51? Well, now I'm at 306, and that is the area that I'm looking for. So 6 times this 51 right here is 306. So now I know that I'm not working. Let's see, this is not doing the thing that I wanted it to do, but that's okay. Let me see. There we go. So now I know that this is not a question mark anymore. I know that 6 times 51 is 306. So what is the missing dimension? It's this 51 centimeters right here. That's my answer. Okay? That ratio table that we just did is skip counting by 6s as quickly as possible. Now, could I have gone a little bit faster and said, well, I know that 6 times 5 is 30. So 6 times 50 would be 300. I could skip there faster, but if you're wondering where should I start? Well, first off, if counting by 1 6 at a time is going to take too long, try counting by 10 of them and then do your skip counting. It will get you faster. All right, let's continue. If the area of a rectangle, I pause again because it said rectangle, so I'm going to put a rectangle down, and then I'll keep reading. If the area of a rectangle is 612 square centimeters, And one of the dimensions is 12. Ooh, I don't like that. Sorry, let me rewrite that. 12. What is the measurement of the other dimension? This is the same problem again, just with a different number. We're just counting by 12s instead. Could we solve it with a different type of model? Absolutely. And I think we should, just to make our lives more diverse. Okay. So what am I going to do? And I'm going to hand draw this, and it's not going to look good, but that's okay. 12 by what is 612? Well, here's my 12, and I'm going to do a small model so that I have lots of room here. What easy thing could I take 12 times to get as close to 600 as possible? Well, I know that 12 times 5 is 60. So doesn't that mean 12 times 50 is just 60 with an extra 0 on the end? Wow, that gets me really close. So I know that 12 times 50 is 600. Okay, but I'm not quite there yet. I need to get to 12. So now I need just a teeny bit extra, and I need 12. I need to make 12. Well, I know that 1 times 12 is 12. So now I have these two areas that both add up to the 612 right here. Is that correct? 12 times 50 is 600. 12 times 1 is 12. 600 plus 12 is 612, so my area is finished, which means that I took 12 times 50 and 1. If I combine those two, I get 51. Is that a lot different? Oh, I don't know why that didn't attach like it was supposed to. Okay, there we go. Is that a lot different than what we did up here in the ratio table? Not so much, but we just made it more visual. Instead of doing just numbers, we did the numbers with the rectangles that represent it, so that we could see basically this area inside a rectangle. If the perimeter of a rectangle is it said rectangle, and I almost kept writing. That was terrible. If the perimeter of the rectangle is 306 centimeters and one dimension is 6. Now this is different because what did it say? Where's my highlighter? Perimeter. That is super important. So that is the distance around. So I'm now counting how long. If I add up all the sides, I get 306. One dimension is 6. Well, what does that tell us about the other side? It is also 6. I like to think of doing combining the sides, subtracting from the perimeter, and then splitting what is left. That's my 3 words that I like to remember when I have a problem like this. Because what do we know? All of it is 306. But if I take away this 6 and this 6, what do I have left? Well, I have both of these sides. If I only want to know what one of them is, then I split it. So this is how I do it. And if this is similar to the way your teacher does it, great. Take both of these sides right here. Add them together. 6 plus 6 equals 12. We just combined it. Check, that's done. The next step is to subtract this from the perimeter. So I'm going to take 306 minus what we just combined. 6 minus 2 is 4. We better borrow from that 3, and then we have our 10 here. 10 minus 1 is 9. Bring down the 2. We have 294 left. Check. Last step is to split. Why do we have to split it? Well, because right now we only know what both sides added together is. It's this number. It says, the question says, what is this other dimension? What is just one of the sides, the other side that we don't know? So I need to split this number. How do you split? Well, you divide by 2. Okay? How would you like to go about splitting that? Well, I think there's a couple ways you could do it, but let's talk about expanded form for just a second. Okay? If I break down the number 294, what do I have? I have a 200, I have a 90, and I have a 4. I could split each of those numbers in half, couldn't I? If I cut that in half, I'd have 100. If I cut that in half, I'd have a 45. And if I cut that in half, I'd have a 2. So if I just add up these numbers, 100 plus 45 plus 2, I would have 147, and that is half of 294. So this is 147. This is 147. Now I know all the dimensions of this rectangle, and it only needed us to know what one of them was. Okay, because we needed to know its width, and we needed to know the length. The end. Here in the second page, we have a few more questions. Some of these I'm going to turn you loose on, but let me get you set up, okay? Ooh, come on now. There we go. 6 people are splitting the cost of a boat trip. The total is $306. Okay? What is each person's share? They're going to split the cost, so we're going to split up this number. How many ways are we going to split it? Well, 6 ways, because 6 people are paying for it. So I have 306 divided by 6. There are many ways you could solve this with an area model, because you could also say 6 times what equals 306. And you could set up an area model where you do your rectangles with 6 times numbers, and then you keep doing your simple numbers until they add up, and then that would go here, okay? I could do a ratio table where I do I'm counting by 6s, and then maybe I would really suggest maybe you count by 10s, and then you keep going until you get to 306. That would be your answer, whatever you stop at. You could do long division, and you could set up 6. Why did I do it that way? Sorry. I could do 306 divided by 6. You could even do a little secret math if you know how to split this number and this number, because it works really well. But I'm going to let you work on that one, okay? You can take it to a teacher, of course, if you need some extra help. But for right now, what I would do is pause this video, choose the method that you think you can successfully do, and do it, okay? My next question says, 12 people are splitting the cost of the same boat trip for a total of 306. Uh-oh. 12 people now are splitting this number up. Jenny says that each person's share will be half as much as in problem 4. Do I agree with Jenny? Well, gosh, I mean, what if we take a number that we know really well? What if we said 5 people are going to pay for something that's $20? Okay, so if we need $20 and we have 5 people paying. Well, we know that that's 4, right? Well, what if I double this number here and I say, okay, instead of having 20 people pay for it, I'm going to have 10 people pay for it. Now, how much is each person going to share? Well, 2 10s fit into 20. So I know that 2 times 10 is 20, so 20 divided by 10 is 2. Look at the relationship between these numbers. We doubled the number of people paying. Now each person pays half as much. Now what does it say up here? So we have 12 people. In the previous problem, there were 6. Okay, so now we have twice as many people paying. Jenny says that each person's share will be half as much as in problem 4. Do we agree? Well, our example says that is true, that if we double the number of people that are paying, each person will pay half as much. I do think it would be worth doing the math, though, to figure it out. So I would take, I'll switch colors here. I would take the number that you're supposed to use, 306, and divide that by 12. But I bet you that number, this number right here, is going to be half of the answer in number 4. I'm going to leave that to you. 3 people are splitting the cost of meals on a boat trip. The cost is $153. What is each person's share? So once again, it's $153 that's being paid, but 3 people are going to split the cost. There's my equation, okay? Pedro says that the answer to this problem will be the same as the answer to problem 4. What? Could that be possible? Let me review what this says down here. This says 306 divided by 6. Let's bring that equation down here and we will compare. 306 divided by 6. Well, I actually see a relationship between these two numbers. What I see is that 153 is half of 306. 3 is half of 6. Wow, so should I get the same answer? I'm kind of thinking we should, but maybe we could use answers that we already know to prove that to be true. Now, you could work out the problem, that would be fine, but what if we took the problem that we said before, 20 divided by 5? We said that was 4. Well, let's double that and double that. How many 10s fit in 40? Well, the answer is still 4. So it looks like if you do the same operation, in this case it's double, and you do it to both numbers, you will get the same answer. Now you have to be careful. You have to make sure it's multiply or divide. We don't want to mess with addition or subtraction, okay? So if this is times 2, that's great. Or if it's divided by 2, that's fine. It looks like that would be true. So I do agree with Pedro, and that is a really awesome thing to notice. So what a cool math fact, okay? And you can explain that in your own words, however you would like. Sorry about that drag mark there. The challenge question says, Orlando and his 4 friends. So that's Orlando. See, all right, I see Orlando and his 4 friends. How many people is that? Well, that's 5. And then it says that Orlando and his 4 friends, those 5 people, joined Michael and his 3 friends. So Michael and his 3 friends, well, that's 4 as well. So how many people do we have altogether? We have 8 people that were, or excuse me, I need to learn math. We have 9 people in this problem. They are going to purchase a gift for their baseball coach, and that gift cost $15.75. The 9 people are going to split it apart, split the cost. Okay, we need to know how much each person is going to spend. This is a challenge question, and this is going to be a little bit more of an interesting one, mostly because we're working with this decimal here. Could I maybe do some division in a different way? I absolutely could. I could. For instance, and it's not secret math, but it's a strategy, is I could take that 1575, watch this, 1575, divide it by 9. Okay, what did I do? Well, I left out this decimal right here. If you do that, you don't want to forget about it because it needs to come back, okay? But let's pretend it's not there for a second. No 9s fit in 1. But 1 9 fits in 15. 1 times 9 is 9, and then I subtract. I get a 6. I bring down the next digit, which is a 7. Then I have to figure out how many 9s fit in 67. Well, 9 times 7 is 63. Subtract again. That looks like a 4 when you subtract that. And then I bring down the next digit, which is a 5. How many 9s fit in 45? 5. And since it fits perfectly, I'm done. Or am I? Remember this? It has to go straight up here. So that decimal you can't forget about, because there's a huge difference. Look at this. There's a huge difference between 175 and $1.75. Now, are there a couple other ways we could do this problem? Yes. One of them, which might be a little bit on the harder side, is if I look at this 75 cents and I want it to be an even number, I could potentially quadruple it, also quadruple this number, and that would give me even numbers to divide. I could do a ratio table trying to get to 1,575, which sounds really challenging at first. But I really do believe that you would do awesome at it, because you would start by taking 9 times 100 to get 900, and then you would be really close to that number. This is a question that if you're unsure about, I would prefer you ask your teacher about, because they might have a strategy that works way better because it matches what they're already teaching you. But because I don't necessarily know what that strategy is, I can only give you some ideas along the way. In another instance, I want you to watch this. And if you have just a second, I want you to think about this. If I take that number, and I've already forgotten it, $15.75. I need to write that down. Could you divide what you have first? We know that 9 people need it. Okay. Well, I know that I can give each of those people $1, right? And if I did, how much would I have left? Well, I would have $6.75 left. Well, could I maybe then break this down into quarters? So I know that everyone is going to get $1 for sure. I have enough. Everybody's going to pay $1, because if everybody gives $1, that's $9, and that's not enough. But I know that at least everybody's paying $1. Well, what if I broke all of this down into quarters? How many quarters would this be? Like literal quarters, like the ones that say 25 cents on them. Well, we know that there's 4 quarters in $1, and then 3 quarters here make 75 cents. So I'm going to take this $6 times 4, right? Because that's a ratio table, basically, that we're doing on our head. If $1 has 4 quarters, then 6 quarters would have 24, because you multiply. So I now have 24 quarters plus the 3 quarters that make 75 cents. That right there is 27 quarters. Look at how friendly this number is, because we're dividing by 9. How many 9s fit into 27? Exactly 3. So that means in addition to this $1 up here, everybody's also going to chip in 3 quarters, which is 75 cents. And that is the answer as well. There are so many ways to solve these problems. Okay, but if you stayed this long, I'm proud of you. Even if you didn't stay this long, I'm sure you were tackling the questions already, and good for you. If you have questions, as usual, ask someone. We love to help. Later.